In this video I want to go over the difference of two squares. So the difference of two squares is a very, very convenient pattern, and it helps us just solve things quicker, okay? If you're able to identify this pattern, you'll be able to factor things, certain things, very, very quickly, okay? And this pattern shows up all the time. And here it is. It says if I have, two numbers, a plus b, or two terms, and I multiply them by a minus b, I'm going to get a squared minus b squared, okay? So a lot of times what happens is we use this in the reverse. We'll see something in this form, a squared minus b squared, and we'll be able to factor it into a plus b times a minus b. All right. So let's look at a couple of examples that work this way, where we're taking something that's already been multiplied together and we're factoring it out, and then we'll look at some examples going the other way. Okay. So I have 9x squared minus 25. All right. Well, if you think about it, this can be rewritten as 3x squared minus 5 squared, right? I can rewrite it as that. So I see a perfect square here and a perfect square here. X squared is a perfect square, right? It's being squared. 9 is a perfect square. So this is going to end up being 3x plus 5 times 3x minus 5. Okay? And I'll do this out for you so you understand why it works. But basically the pluses and the plus and minus make the middle term drop out. So if we were to FOIL this back around, we'll get 3x times 3x, so that's 9x squared. We have that, okay. Outside is a negative 15x. Inside is that positive 15x, okay, and that's going to turn out to be a 0, right? And then at the end we have negative 25. So that's what happens with our pattern, is that the middle term drops out because we have a negative and a positive of the same number, okay? So let's do another example. Let's do maybe a harder one here. Okay, so example 2. Let's do something like let's do 169x squared minus 1. Okay? So the tricky part about this one is this minus 1. That's actually, 1 is actually a perfect square, right? 1 times 1 is 1. So we can rewrite this as 13x squared minus 1 squared. Okay? And then that turns into 13x minus 1 times 13x plus 1. All right? So that's a little bit of a tricky one because of the 1 there, but nothing to be too freaked out about. How about this one? This is another example we can do. Example 3. This will be my final one. Say we have 49x squared minus 36y squared. Okay? Things can look like this. And all we have to do is say that this is actually 7x squared minus 6y squared. Okay? So this can factor into 7x minus 6y times 7x plus 6y. There is a pitfall that you could possibly get confused with pitfall. Okay. This here, and you might know about imaginary numbers, you might not, but if I have something like x squared plus, or a squared plus b squared, I can't factor that into anything useful without using imaginary numbers, okay? So keep that in mind. This is not the pattern. The pattern is a squared minus b squared. Thank you.